Welcome to the trading floor. Now, I want you to think of your exam paper exactly like a high-stakes trading floor. You have a highly limited currency, which is your time, and you need to make split-second decisions to invest that time where the return on investment or your mark potential is the absolute highest. Okay, let's dive right into this explainer and crack the code on one of the most notoriously challenging topics in the Cambridge Computer Science syllabus. Whether you are sitting the 0417, 0478, 0983, 0984, 2210, or especially the advanced 9618 A-level paper, you already know that grasping the intricacies of networking hardware is absolutely vital. But there is one specific area that continually trips up even the most thoroughly prepared candidates, and that is fiber optic cable characteristics. Today, we're going to look at this topic entirely through the lens of Cambridge Principal Examiner reports. We're going to dissect exactly what the examiners are actively looking for so you can stop guessing, stop leaving easy marks on the table, and start securing those top-tier grades.
The examiners themselves are literally telling us that candidates are fundamentally misunderstanding how to apply their knowledge of fiber optics to complex, real-world scenarios. We see this all the time with real Cambridge past paper questions, like the ones you might have seen in the classic 9713 papers or the current 9618 ones. Let me introduce you to two types of students we constantly see. First, we have Alex. Alex overloads his answers with raw computer science facts about fiber optics, but includes absolutely zero analysis. Then we have Sam. Sam rushes, completely misses the specific command word requirements, and writes an answer that doesn't actually answer the prompt. If we put their flawed answers side by side, they are just covered in red pen marks from the examiners. We aren't just going to review what a fiber optic cable is today. We are going to fix these fatal misunderstandings. We are going to show you exactly how to structure your thoughts the way Cambridge actually rewards. The goal here is to shift your entire approach from basic rote memorization to strategic high-scoring analysis. Because standard definitions, they just aren't enough anymore.
Here is our roadmap to securing those top marks today. We will go through 1. Mastering core principles, 2. The procedural framework, 3. Evaluation and critical analysis, and 4. Top examiner warnings.
Let's move right into Section 1, Mastering Core Principles.
This right here brilliantly illustrates the difference between an average candidate and a top performer. Average candidates, like our friend Alex, rely on isolated facts. It's like having a single puzzle piece and trying to tell me what the whole picture looks like. If a question asks about fiber optic characteristics, Alex just writes down total internal reflection, or it has high bandwidth and expects full marks. But examiners want to see connected, conceptual understanding that transfers to unfamiliar contexts. This is where you absolutely must use the Peel framework. That stands for point, evidence, explanation, and link. Instead of just stating a fact, you make your point. Fiber optics have incredibly high bandwidth. You provide evidence, data is transmitted via pulses of light. You add your explanation, this allows for massive data throughput without electromagnetic interference. And finally, you link it back to the scenario. Therefore, in this specific corporate backbone network, it prevents bottlenecking during peak hours. That is how you use evidence-based reasoning to show why those characteristics matter in the broader architecture of computer science.
Cambridge isn't just testing if you manage to read the textbook cover to cover. They're actively testing how you process information under pressure. To master the core principles, you must hit these specific cognitive domains through precise definitions and systematic analysis. First, knowledge and understanding requires perfect recall of precise definitions. Second, application means taking those fiber optic principles and applying them to a scenario you have never seen before. And finally, analysis requires you to break down causal relationships. Why exactly does changing the cable type affect the entire system's performance? Hitting all three of these domains is your ticket to a top grade. Now, before we continue and break down the specific command words that unlock these cognitive domains, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
All right, let's dive into Section 2, the procedural framework.
What's really interesting about this next slide is how we capture process marks through what I call the computer science success blueprint. This step-by-step sequence is the exact standardized methodology examiners expect to see when you are tackling complex, multi-step calculations or extended responses. Let's break it down, because this is where students like Sam lose all their marks by rushing. When you get a massive scenario question on fiber optics, step 1 is to deconstruct the question. You have to decode the command words. Does it say identify, describe, or evaluate? Step 2, pull out the relevant numbers and constraints. Step 3, choose your formulas or logic principles. Step 4 is where way too many candidates drop the ball. You literally must execute with clear, working notation. The examiners explicitly state in their reports that they award method marks even if your final calculation is dead wrong, but they can only do that if your notation is clear. Finally, step 5, present your conclusion using strict Cambridge terminology. Follow this loop, stop rushing, and you systematically harvest every available method mark.
Because practical application develops real-world programming skills, your algorithmic thinking must encompass decomposition, data structures, efficiency, and thorough testing. Now you might be sitting there wondering, wait, why on earth are we talking about programming in a networking and hardware topic? Well, the syllabus intentionally integrates these concepts. If you are asked to design an algorithm that calculates data packet transmission times across a fiber optic network, you need this exact framework. You have to break the complex problem down, choose the right data structures to store the network node data, write efficient pseudocode, and explain how you would rigorously test it. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Okay, let's move right into Section 3, Evaluation and Critical Analysis. Let's dive into higher-order assessment objectives and see how top-scoring candidates evaluate alternative approaches. I want to run a quick interactive workshop with you right now. Imagine a 60-second timer on your screen, and you are looking at a complex data table comparing fiber optic and copper coaxial cables. Challenge 1 is the data scan. You need to extract the core trend immediately. Evaluative thinking means recognizing that there is rarely one single perfect answer in computer science. To score the highest marks in comparative analysis, you must identify both similarities and differences using comparative connectives fully supported by evidence. Don't just list their features like our friend Alex does. You need to analyze the trade-offs. Yes, fiber optic has incredible bandwidth and low attenuation, but you must acknowledge the limitations. It's incredibly fragile, difficult to install, and expensive displays. Use words like whereas, conversely, or on the other hand to build a tightly structured comparison, and always justify your final recommendation based on the specific scenario provided in the prompt.
When analyzing the quality of your algorithms within the context of fiber optics, examiners specifically look for your evaluation of time complexity, space complexity, and how edge cases affect performance. Let's move to Challenge 2 of our interactive workshop, Finding the Flaw. If I showed you a sample paragraph that perfectly describes fiber optic speed but ignores what happens when the network goes down, you'd know exactly where it loses marks. Again, this is about linking hardware to software principles. If your algorithm models data flow through the optical network, how does it scale when the network traffic suddenly doubles? That's time and space complexity in action. And most importantly, what happens when something totally unexpected occurs? How does your system handle extreme edge cases? Which brings us perfectly to a major pain point the examiners highlighted.
Let's move to our final section, Section 4, Top Examiner Warnings. We pulled the top mistakes directly from principal examiner reports so you can avoid them entirely. Examiner reports repeatedly flagged 3 critical areas where candidates just hemorrhage easy marks. First, in your calculations or network algorithms, you must account for overflow and edge cases. What literally happens if the data exceeds the maximum bandwidth of the fiber optic channel? Second, boundary conditions, testing the absolute upper and lower limits of the system. And third, perhaps the most tragic mistake of all, providing answers that are not specific to the given context. Remember Sam? Sam writes a beautiful textbook perfect essay about the total internal reflection of fiber optics, but completely ignores the actual context of the question. If the past paper asks about setting up a local area network in a small, tight office space, do not give an answer tailored to a massive transatlantic submarine cable. You have to decode the context. Think of our 3 rules for top marks: command word decoding, Peel framework application, and managing your time management matrix.
And this brilliantly illustrates another major pitfall. Examiners note consistent confusion over terminology, making it absolutely mandatory to define your terms first. Words have very specific, rigid meanings in the 9618 syllabus. When candidates mix up terms like bandwidth and throughput, or confuse attenuation with dispersion, it immediately signals to the examiner a fundamental lack of foundational knowledge. Imagine the examiner taking out their red pen right there. The quickest and most effective way to protect yourself in an extended response is to explicitly define the technical term in your very first sentence before you apply it to your argument. Transform those red marks into green check marks by showing the examiner you know exactly what the vocabulary means.
A fantastic strategy to combat this exact terminology confusion is to create your own personal mnemonic, using the first letters of the key terms you need to remember. Let's do a speed round right now. Think about the core characteristics of a fiber optic cable: bandwidth, attenuation, security, interference, cost. Take the first letter of each of those words, and that spells BASIC. Just by remembering the word BASIC, you instantly have 5 distinct, highly relevant talking points ready to deploy in absolutely any comparative analysis question. Build these cognitive shortcuts into your daily study routine so you aren't sitting there panicking, searching for words under the immense pressure of the exam clock.
As we conclude this explainer, I want you to ask yourself a hard question. Does your current exam strategy systematically capture every single method mark and critical analysis point required by the Cambridge rubric? Are you just memorizing facts like Alex, or are you actively practicing the procedural framework? Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.